All right. We are back with another edition of the MedTech Jam Session with Chris and Mike D. Chris.
Hey, Mike. Good to see you.
So last time we chatted, you were still waiting to get power back on. You were living in the RV. Now the lights are on down in Mississippi.
Yes. And the fence is put back up and the lights are great and still working in the RV.
Okay. That's good. Pigs and chickens can't get loose now.
They can't. They're running loose, man. Everywhere.
Awesome. All right. Well, today we have another amazing guest, and we're going to switch gears a little bit and talk about personalized orthopedics at scale. Also, our guest is going to talk about how he's working directly with some of the strategics as well. He's got a multi-pronged business. The company is called Oxford Performance Materials, and they are bringing to market new materials or different materials than, titanium, stainless steel, cobalt, chrome, polyethylene, all the, traditional metal and plastic parts. It's not even PEEK, it's PEC. So we got to find out what PEC is. Do you know what PEC is, Chris?
Yes, it's poly.
All right, well,
we're going to rely on Scott to break that down.
Oh, let's do that now.
We're talking about chickens. We're talking about pecking. Come on.
All right. Let's welcome to the MedTech Jam Session, Scott DeFelice. Hey, Scott.
Hey, guys. Hey, Mike, Chris.
Well, I've spent a little time reading about Oxford Performance Materials and OsteoFab technology, but before we get too far into the weeds about your tech, so I think it's got some really interesting and then timely applications in musculoskeletal. Tell us a little bit about how the company has evolved over time, because you've been at it for a while.
Yeah. So Oxford Performance Materials, we've been around for over 20 years. At our core, we're a PEC material science company. So we eat, live, and breathe PEKK. So we're a platform technology, and we've built a couple businesses off the technology platform already and exited them. We built a materials product that we sold to a chemical company. And then, we developed a 3D printing technology actually with NASA, Northrop Grumman, and Boeing for space and defense applications. And we exited that to aerospace defense company. And so, but we've always been in orthopedics and, starting first in raw materials and then moving into 3D printing, which we've been in for over a decade, doing our cranial implants that are distributed in the US by Zimmer Biomet. And outside the US, we go direct with those products. So yeah, we've been around for a long time, but the primary focus of the business today is this personalized orthopedic solutions, these metal-free solutions that have, lots of wonderful benefits.
Yeah, metal-free orthopedics is kind of a buzzword right now. Tell us the difference between PEC and PEEK. I think a lot of our listeners are familiar with PEEK, maybe not so much with PEC. Can you kind of compare and contrast those two materials? They're similar, but not the same.
Sure. So, they're both in the same polyaryl ether ketone family of polymers. So there's a family of polymers with lots of E's and K's, and PEEK and PEC are in that family. That's kind of where the distinction ends. So, Chris, from spine, everyone like PEEK's going to be great, but then they found out bone didn't grow on PEEK. And it was like, well, it's not so great. So this is where PEC is just a different enough chemistry so that it pulls down proteins onto the surface of the material and initiates bone growth. And also it's the same reason why it's bacteriostatic. So PEC has a different biologic response than PEEK that enables for a very virtuous healing and bone on growth process to happen.
So do you feel like that allows you to, let's say, have better in-growth, on-growth, and maybe use less biologics? Or is do you come at it to promote it that way?
Yeah, so there's studies that have been done just in synovial fluid and in animal models. Yeah, the bone just grows on PEC. Now, most of our clinicians will use some form of biologic. They just have a comfort with it, and it's a belt and suspender sort of thing. Yeah. I mean, ultimately, is that going to be an opportunity to use less and lower cost? I think the studies need to be done. But we know right now we're getting pretty tremendous bone on growth and ingrowth into these structures we build. And so there's just a lot of comfort with what we're doing today.
That's great. Yeah, I mean, one of the big trends too. So we've hit on material, you've hit on personalization, and one thing we haven't hit on. How would you compare something like this to porous peak?
Yeah, so you can make a porous peak, and I think Globus has that product now for porous peak, and you still don't get apposition. You get bone growing into a porous structure, but it's not really mechanically attached to it. So
Got
what's
it.
the value of that? I'd argue it's limited, and really what you need is real robust apposition. It's the type of stuff we can demonstrate with PEC, and really it's the only polymer that does that.
Okay, good.
On growth versus ingrowth. It sounds like your material facilitates ingrowth of the bone into the material, whereas maybe peak, it may just attach itself loosely, but doesn't give you that robust.
Yeah, so peak doesn't attach itself, and PEC will grow into an open structure and then be opposed to it, be attached to it at the same time. So it does both.
Gotcha. You've been the beneficiary. We've talked to some of our other guests about how platform technologies have evolved, which has been a facilitator to what you are building. And so one of those was probably going to be 3D printing. The 3D printing world has evolved tremendously over the past 20, 30 years, I guess, maybe longer. I'm not sure. How did that change things for Oxford when you guys were able to start 3D printing these things?
Yeah, it was a big deal. In fact, that story goes back to, oh gosh, it's probably like 2010. And a surgeon came up to me and he's like, "Hey, love your material and spine. It's awesome. Can you print with it?" And I was like, I'm not sure. And so I brought my CTO, Tony, in. I said, "Tony, hey, can we print with this stuff?" And he goes to the drawing board and he's making all these squiggles and more of these lines and wages are going up. And he's like, "Hey, you know what? It's going to be really good to print with because it's super sticky and it sticks to itself," which is a big part of being a good material for 3D printing. So yeah, so we early on, once we recognized that, we were able to move in the direction because the systems and technologies had begun to evolve to the point where you could also process and print with the proper machinery. So yeah, there's been a convergence of technology.
Mm-hmm.
There's a convergence on the material side, and that's where a lot of our IP is, right? We developed the material science. So our patent portfolio is around process and material technology and application technology. We developed the material science so we could print with it. Then the machines became available. Then the software ecosystem continued to evolve.
Right.
And now we're at this stage where AI is further facilitating that, where now you can not just do this, but do it economically, do it fast, and do it efficiently.
That's fascinating. I think you're right. Did you have to build your own machines at first, or were you sort of counting on the 3D printing evolution to take place, and then you were able to sort of plug in your powder or your material and use sort of an off-the-shelf, if you will, 3D printing process?
Yeah, it's kind of a hybrid. So we developed the material that would be suitable for an existing machine platform with modification. So we brought some technology to that as well.
Yeah. I imagine these are the marrying of two technologies probably required some adjustment to what, the core 3D printing companies were building using metal or nylon or whatever, some of the other materials that they use. So
is there a lot of companies out there in the OEM space that are utilizing the same materials, okay, but their IP and their method patents allow, we'll say, to be truly competitive? When you look at that from your angle, right, how can you protect what you guys are doing relative to the other creators of PEC? And I'm sure that's through method patents and things of that nature. But are you really starting to see it get competitive?
Well, no one's going to be able to compete with us in orthopedics until 2034, because that's our IP landscape goes out that far. And we're actually very active in developing technologies that will continue to push that out another decade. So we think, we're early in. We sort of captured all the real interesting bits of IP, patented it all, and now have a good long opportunity to exploit it. So, I think in orthopedics, we're very well protected for a considerable amount of time.
Great.
Yeah, that's awesome.
Great.
Are you a medtech company prepping for a big product launch and are struggling to get the attention of your sales team so that they can hit the ground running? Or Are you a medical device sales professional who is frustrated because you have to go to one platform for sales training, another platform to access selling tools, and then go to your email to check for important company updates? Well, here at ConveyMed, we've built a better way. Welcome to Convey Connect. Your bespoke, company-branded mobile app will become the single source of truth for your sales reps, resulting in a better trained, connected, and engaged team who will crush quotas. Organize your training content to accelerate Salesforce readiness. Customize your sales library so your reps can easily find and use the selling tools that move prospects to customers. Build culture and camaraderie with your own internal social media feed right inside the app. Built on a secure platform and customized for your needs, we can get your mobile app deployed to the app stores in a matter of weeks. Please visit conveymed.io to learn more and schedule a demo.
On the technology side, you also alluded to how software has evolved and is allowing you to more quickly create these 3D printed customized. Talk a little bit about that. How has the software made it easier, faster, more predictable, more accurate? And how are you integrating even tools that have AI as well into your process?
So, we have a project called The Last Mile. And the last mile is really what are the technologies required to bring this to scale? Now, the manufacturing technology, the design, is scaled already. We can do a lot of that. We can do a lot of that really fast. But that last mile is working with the surgeon to, effectively come up with designs that are clinically appropriate. And so now lots of tools are coming to play, right? So we already see now AI in terms of segmentation. Now, when we first started, a segmentation could take a few hours. Now we're doing a segmentation in minutes, right? That's a big thing. We have a platform that, a design platform where surgeons go online and get on the platform, download their files, do all this visualization. And so that's a tool that we now have that we didn't have 5 years ago. So that's making it really easy for surgeons to say, okay, I could see this thing segmented. I could see different design features. I'd like to do this. I'd like to do that. And all that now happens in real time with real good visibility tools. So, that's happening. And then there's a lot of small AI things that are starting to happen where you just have processes and procedures that are, what we call closed system problems, where you can use AI to generate documentation. And so that's starting to happen. So the final frontier, the final step is ultimately going to be design. Can you have AI design these solutions with minimal human interaction? And we're seeing that already in our CMF business. Now, we've done over 5,000 cranial implants since we started. And now the software, it's not validated yet. We're just looking at it. It's not in production yet for us. But we don't see any problem with actually the simple orthopedic problems being done by AI. And then the final step will be, okay, now we're more talking about complex reconstruction problems with a lot of adjacent hardware and other things going on. Do I believe that these tools will ultimately be able to conquer that? Yes, absolutely. It's going to happen. And honestly, I don't believe it's that far off either. I think there's a few groups, there's like 4 or 5 groups around the world who are pressing hard on that topic. And, I think within 24 months, we're going to start to see the lower end of our complexity be able to be addressed by these tools. And then ultimately the most complex cases, to me, it's the sort of 2 to 5 year time horizon where we're going to see a lot of continued evolution. I mean, just look at your Chat GPT of 24 months ago versus today.
Yeah.
Different animal, right? And that's going to happen.
Yeah. I mean, the pace of change is startling. And I might take the under on that 2 years if we were betting.
Yeah. It's funny because pace of change is one thing. And then we think about cycles and we think about how that pendulum swings. Okay. And I remember, coming into Medtronic and titanium had been king as it related to cages. And then all of a sudden PEEK was shifting in a massive way into becoming king, and it remained there for a while. Then titanium came swinging back. Do you see the next swing not being to PEEK, but to PEC.
Yeah, I mean, honestly, that swing's already happening. But when I take a longer term view of this industry, because I'm an outsider, right? I come from aerospace, defense, manufacturing, material science, right? So I come at this industry to somewhat of an outsider's perspective, and to me, it's like, well, in the last 100 years, you've had 3 or 4 materials, right? Now, in the other markets I deal in, those evolutions have been, much more rapid. Moving from steel to aluminum to composites in aircraft, for example, right? And those adoptions have been more rapid. Now, look, this is a conservative industry. You got to prove it. You got to take your time. You got to do it right, and that's all appropriate, right? That's why I like to say we've been in stealth mode for a longer time than more companies have been in business, right?
Right.
Because you have to do the science. You got to prove it out. You got to do all that stuff. But we are at this juncture right now where there was no alternative to metal, right? There just wasn't. And look, the shortcomings, we knew that they're infection prone, right? We knew that they're too stiff and too strong. We knew that they release ions. Like, we knew these shortcomings, right? But there wasn't an alternative, so why bother thinking about it too hard? Just do it the best you can. Now with PEC, we're showing there is actually an alternative. And PEEK isn't really in this play because it doesn't have the right biologic response, and you really can't 3D print with it beyond this little FDM process, which makes 1 implant at a time. We can make 1,000 implants overnight, right? So it's a totally different scale of production. So yeah, I think the recognition that metal has shortcomings, that surgeons and clinicians are really willing to talk about it now more. We've got a bunch of KOLs, and they wake up every morning thinking, metal is not the solution. It's really my problem, right?
Yeah.
And they're figuring out how to get away from it. Infection is huge, right? You can't talk enough. People ask me all the time, well, what's the most important thing about what you're doing? Love my material, love my technology, love the fact that the bone integrates, but gosh, the fact that it's a bacteriostatic and we don't get a biofilm is huge. And we're seeing it every day. We see it when clinicians because they give us the most complex cases to start, right? They give us the disaster cases is what we start with. And we see the results. And they debride them, they put in a PEC implant, and they're not getting infections. So I think that's just a huge deal that we can now bring to the table.
Oh, there's no doubt. With the antimicrobial piece, it's always been baffling to me that we've been hearing about this and talking about this for 25 or so years. And it's like silver, and we're going to do this, and we're going to do that. And it's just really been strange to me with the infections being what they are, right? And which is substantial. I mean, we're talking minimum 20% infection rate, regardless of where you are in the body, per se. And why has it taken so long for us to get to a point of truly being able to promote antimicrobial implants that are truly infection prevention?
Yeah, it's because, the material you're starting with is just problematic, right? Like, so OPM, people will call us a deep tech company, right? Because we go deep in the value chain. Our IP starts with how to synthesize PEC, really deep in the technology value chain. The deeper you go into the value chain, the more you can make fundamental change further down. So that's what we've done. Like, we've dug deep into this PEC value chain and come up with a way that we have a material now that's bacteriostatic, right? And now we can print with that material. And now you can make implants personalized to people that aren't going to get infected. It's a big deal.
It is a big deal. Have you guys done a lot of trials and or clinical, maybe publishing even, or affiliates of yours publishing on this antimicrobial impact?
Yeah. So the best data we have to date is our 5,000 cranial implants that have been done, because we're the OEM on those CMF implants. So our infection rate is 1.5%.
Wow.
The peak analog materials is 20%. So that's just a big body of knowledge. And then we've done a bunch of studies with Dr. Thomas Webster looking at, first, does this happen? Can you measure the colony forming unit reduction, right? And so that first part of that research was, yes, it's absolutely happening. And then the second part of the research we did was why. That was the big question. Like, what the hell is going on here? You guys aren't growing bugs, right? And so It really came down to the hypothesis Dr. Webster had was that there's some protein selection going on. Proteins that are endogenous in the body are likely depositing on the implant. So he did a bunch of studies and he found out that was in fact the case. I'll get a little geeky on you here.
Come on.
But the surface energy of the endogenous proteins in your body, fibronectin, vitronectin, lubricin, those proteins have a surface energy that is comparable, very similar to the PEC. So as far as those proteins, because those proteins are workhorses, they go do jobs, right? They're in the body and they react to healing and they go do jobs. And they find that when they see this PEC implant, they're like, oh, it's bone. We'll do what we normally do. So we're just getting natural healing with this synthetic material because we happen, and this was luck, honestly, right? We didn't design it to pull down the proteins. The polymer just happened to have that right property to pull down the proteins. And that is why we're getting this effect.
That's amazing.
I think
Proteins
that
sort
right
of take up sorry, Chris. So the proteins sort of take up residence on your material and
Yes.
serve as a protectant, if you will.
Yeah, well, they go do their normal job. So the proteins do two things. They prohibit bacteria from being able to set up shop, and then they promote bone growth. So the proteins get there first, do their job, and then the bone starts to grow and it does its job. And that's why we just get very good healing, bone healing.
That's amazing. So now let's switch gears, or let's keep going down this pathway. What are the areas, the clinical areas you guys are focusing on right now? Where are you having the most success? Where do you see the biggest opportunity?
Yeah.
So this technology in the next 24 months, let's say.
Yeah. So legacy was CMF and spine, right? We've been doing both of those for over a decade. But then we saw, the likes of Restored and Paragon and others moving into this personalized implant space. And we felt to ourselves, hey, we got a better mousetrap than this. So, we didn't have to think too hard on where to go next. Lower extremity was where a lot of that early work happened, and foot and ankle. And so we moved into that space. We picked up a bunch of great KOLs in that space and been really successful sort of replacing 3D printed titanium or cobalt chrome, in a total talus and an arthrodesis. So that's sort of where we started. But very quickly, the market had its own say, right? You put a technology out there, and then the market and the clinicians, they're actors in their own right, and they get to decide. And so quickly we got into oncology cases because they like the radiolucency, they like the bacteriostatic. Of course, they like it could be personalized. And so we started picking up oncology cases. And then not too much after that, we start to see interest in arthroplasty. So first case was a total elbow, then both sides of the total shoulder, knee spacer, tri-flange, moved into all those indications. So now we have, a really multi-segment business. And the interesting thing really about this business is you get all the premier relationships, right? You get all the premier hospitals and all the premier docs solving the most complex problems. So, every institution, we're finding no problem getting through VACs, whether it's Stanford, Georgetown, Rothman, Ford. I mean, we're getting into all the top clinics with all the top docs because they want this tool to solve their problems. It's a great way to break in, and that allows us then to carry in other products through those relationships.
That's awesome. So, I mean, as a provider of these materials, of course, I understand the personalization side of the business. I can't believe that every strategic out there isn't banging down your door.
Yeah. So that's an interesting question. People always ask me, Zimmer's your partner all these years. They not see the value. And, I think you have to appreciate the disruptive nature of this technology, right? Because it's already demonstrating it can go everywhere. And so, Chris, you were an M&A, and you got to go to your boss and say, hey, there's this company, there's this great technology, there are all these segments, they're solving the biggest problems in the industry, infection and metal issues, and they're solving all these problems. This would be great investment. Let's do something with these guys. That's the good news. Then you got to tell them the bad news. It's disruptive to so much of what we do. How do we manage that, right?
Yeah.
So
by default,
that's the reality. And our feeling is that we just got to stick to our knit. We
Yeah.
just got to continue to do what we're doing and continue to grow the way we're growing.
Yeah.
And, you know, all that stuff will take care of itself.
That's
Yeah.
it's
funny
classic
because
innovator's dilemma, you know, for the big.
Oh, yeah. You're a disruptor. And so, you know, I think as you look at this, you know, Medtronic's out there and they just did the licensing deal with NanoV
So, yeah.
to basically, you know, in a refresh of their Titan portfolio that they purchased several years ago, maybe among other things. But when I think about this and where it's going, and this is the whole idea of the adage of going where the puck's going to be, right? When there should be a, pardon my pun, material shift. I mean, there really should be for the benefit of any patient. And so it's like, you know, you're one entity that has obviously a lot of growth that's happening. And I get that. But how is it that this is going to get to where it's such a bolus of impact that every patient can benefit? What does that look like?
Yeah, so that's the tipping point, right? You're talking about a tipping point. And so we've always felt there's a few stages, right? So the first stage is you're going to get your early adopters. And, you know, those are docs we go to. It's interesting who they are. Sometimes they're guys late in their career and they're like, I want to do something interesting. Sometimes they're just earlier in their career and they don't know they're taking a huge risk, right? But we find those early adopters, and we've sort of gotten those guys already. We got a lot of those early adopters who want to bring new technology. Now we're starting to move into, you know, more of the mass market opportunities, you know, whether it's a total ankle, a total elbow, a total shoulder, total knee. Those are all things we can do. So, you know, we've got to now move into that next phase where we're starting to bring out products that can be applied, still personalized, but at much larger scale, right? And then I think the next stage will be strategic interest along those lines. Now, it may well be that it just happens too late for those guys and we just IPO and we just go at this thing all on our own. And that's a perfectly good path, and we're super happy to go that way. You know, I've got two sons in the business who are, you know, young guys and aggressive, and, you know, I know what they want to do. They want to conquer the universe. So so it's a great dynamic. You know, the world is littered with companies who, you know, didn't see the next wave, right?
That's right.
And so it happens. It just happens. I don't underestimate how hard it is for strategic companies with billions invested in their supply chains and their products that they've got on the shelf and their business model of having inventory heavy solutions and all those barriers that created for them so they can get outsized margins. And all of a sudden there's this technology that says, well, that model's going to turn it on its head. I appreciate that that's a super difficult decision, and more than likely, you know, it's going to take a lot of courage for someone to take that move.
That's awesome.
It's going to take time too. I mean, you know, to your point, the diffusion of innovation curve, you're at that early adopter stage, but there's this whole group that's got to move your way. And I love the way that you're approaching it, which is you're tackling the most difficult, most challenging cases first, because your material solves unique problems uniquely. But I get your point. There's an opportunity to kind of scale personalization. Do you think there's going to be another sort of technology requirement, as we talked about earlier, like there was 3D printing that unlocked value for you? There was all this software and AI that has unlocked value. I wonder if there's another sort of technology we're not thinking about that's going to unlock the value that will allow you to scale. Yeah,
for sure. I think about this one a lot. So, you know, right now we're making personalized implants. When we started, that personalized implant just filled the shape, right? Like cranial implants. And now we're doing these load-bearing personalized implants. And we do, you know, finite element modeling on new cases. We'll do benchtop testing on new cases. You know, like we just don't go into a space if we don't feel, you know, because our material is mechanically like cortical bone, we could sort of stay in the general anatomical envelope and we get the right profiles mechanically to perform. But that's sort of simple mechanical analysis, right? But the piece that the question you just asked is, okay, what's after that, right? And to me, That's when you have iterative design, but also taking into account, the patient, their gait, all these other inputs that would drive you to truly personalized solution. Mike weighs 200 pounds, he has this gait. There's all these other inputs that need to be baked into that cake ultimately. So that's something we're keeping a close eye on. There's others, people are working it. You got Fraunhofer working this, and in their gait analysis lab, the folks at MIT are working it. So really smart minds are working this problem because they realize that the rest of the technology stack, and that's the way we think of our business, it's a stack, right? So materials, process, application, AI, these are all parts of the stack. And the smart minds are working that last piece. And I'm really excited about that, and we track it closely.
That's great. I think in our lifetime, okay, we're all probably right around the same age.
Yeah.
But I would say in the next decade, could we go out on a limb and say everything that OPM is doing is going to become standard of care?
I take that bet. So the first place we're going to become the gold standard, and that's the thing to watch, right? Can there be a segment where we are the gold standard? And I think we're within a year or maybe a little bit more of being the gold standard in arthrodesis and foot and ankle.
Awesome.
We have the best solution. The results are clear. There's clinical studies coming up this summer. Dr. Cooper and Dr. Gross have got those studies going. Relatively small series, but we're seeing the fusion rates 100%. We're seeing, everything is just as we expected. So I think it's critical that we become the gold standard in the segment. And if we can do that, then I think that sort of softens the target some. And I think we're on the threshold of that.
That's great. That's great.
Yeah, I like the systematic approach. Let's pick a segment that we can own, and then you can start systematically picking off other segments that make sense: oncology and revision, infected total knee, infected total hip, infected total shoulder. Those are huge problems, not great solutions. Love it.
Very true. Very true.
So you guys are in growth mode. You're growing fast. You're profitable, sounds like. What's next? Are you guys raising money? You're raising growth capital? Like, where would you like to see the company in the next?
Yeah. So I guess first thing on our business model in general terms, we see a lot of orthopedic companies raise a lot of money, raise early, get seriously diluted, and burn hot, and then hope to get to a strategic exit, right? We don't like the model. We're just not going to do it. We don't think it necessarily pans out, especially when you're doing fundamental technology, right? If you're just knocking something off, a little twist, build the business, and then you could sort of bring that into a large strategic and rationalize everyone. I get that model. But for us, we really are thinking of continuing to build the business so that we can grow it profitably. Now, that makes it easier for when you are at the point where you are looking for growth capital. So we are actually in that process now, considering something that would allow us to scale everything we've done at sort of, 5 cases here, 10 cases there, 20 cases there. Let's see if we can then make the investments to scale it much more aggressively. So we're looking at those opportunities as they come along.
How big is your facilities right now, just in general?
Yeah, so 16,000 square feet in South Windsor, Connecticut.
Okay.
So all our manufacturing is done in-house. The only thing we do out of house is part cleaning. So, and so we're in the process of bringing that in as well. So yeah, we control all the technologies. The printers are in OPM. The materials process technologies in OPM. The labs, everything's there, and the designers.
That's great. That's great, man. You built a great business. And I know it takes a lot of vision. It takes a lot of blood, sweat, and tears. I think it's very cool. You got your sons on board.
Yeah.
The thing is, when you're starting a business, you need people to work for free. So that was the program for the first years. Now we pay them, though.
There you go.
Yeah. But you're not wrong.
Yeah.
Well, Scott, thanks for joining us. Where can people find you to learn more about Oxford Performance Materials and your team and kind of what you're building? If people are interested in learning more, where would they go?
Yeah, I'm a big user of LinkedIn. So connect with me on LinkedIn. I'll absolutely accept. And, if you're a surgeon and you want to learn about the technology, That's a great way to connect, or info@oxfordpm.com. That's another great way to connect. And yeah, we love those opportunities where we can get in front of the doc and present the core technology, usually pretty stimulating discussion. And also if you're a distributor and, we're continuing to build out distribution in the US. We've just signed distribution in Canada, the UK, Europe, and Israel. So now we're in the, moving internationally as well, and have taken first cases OUS. So yeah, a lot of opportunity. I'd love to talk with anybody who's got an idea on how they like to collaborate.
Nice.
That's great.
Well, congratulations on what you've built. Thanks for joining us. We will be watching your progress very closely, and thanks again.
Okay. That's a good chat with you guys. And
yeah, you bet.
Same here, man.
All right. That's going to do it for another edition of MedTech Jam Session with Chris and Mike D. You can find us wherever you get your podcasts. Thanks so much.